Hello grade 8, welcome back to another video. Today we will be doing exponents. I hope you found this video informative. If you are struggling with algebraic expression, I just posted a video yesterday which will help you guys master that part of your maths. Now, without wasting any more of your time, guys, let's get right into it. Okay, now this is exponents. Normally, with exponent, you will get something like this. 2 to the power of 7. This means power, right? So this is the exponent. This is what qualifies this 2 to be an exponent. If it's just 2 like this sitting by itself, is it still an exponent? Well, it's not. We can just say, but we can still say because there's power of 1 to every number that is standing by itself, as I have said on my previous video. Now, this will qualify it as an exponent. So this power here is an exponent. And this number is a base. Now the base is going to be multiplied this times, right? You're going to multiply this base this many times. So when we have 2 to the power of 7, you're going to say 2 times 2 times 2 times 2 times. You're going to have 7 2's multiplying each other. So when you go into your calculator and say 2 to the power of 2 to the power of 7, that's 128. Now let's say 2 times 2 times 2 times 2 times 2. Let's count them. 1, 2, 3, 4, 5 times 2 times 2. I think that's 1, 2, 3, 4, 5, 6, 7. We still get 128. Now, when you multiply 2 by itself 7 times, it takes up a lot of space. But if you just say 2 to the power of 7, that does not take a lot of space. Now this 2 is a base, and this whole thing is a power, 2 to the power of 7. Now exponents and powers involve repeated multiplication, where a number is repeated by itself many times. Now examples are here. You can try these examples, and when you are done, you can play this video and resume it. Now, this is how you do it. 2 to the power of 5. That's 2, 3, 4, 5. Let's count them. 1, 2, 3, 4, 5. So that is 2 to the power of 5. That gives us 32. And then we say 2, 2, 3, 4, 5. We multiply 2 by itself 5 times. 1, 2, 3, 4, 5. And that's going to give us 32. This is time consuming. This one, straight to the point. That's a trick that mathematicians came with to make these multiplications very simple. Now just imagine in your calculator multiplying 3 by itself 15 times. Well, what a dread. That is going to be 3 times 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I am tired. I am exhausted already by doing all that. Why I could just take 3 and say to the power 15 on my calculator and get my answer. Well, that's a very big number. I don't blame, because the amount of work I had to do multiplying these 3's is a lot. So let's in the calculator. 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's the same number. Oh, that is exhausting. I'm sweating. All right, now let's continue. I hope you understood that part, right? Why are powers there? Now we are gonna go through our exponential laws. So the first exponential law says when the bases are the same, you add the exponents, right? So a to the power of m, a to the power of n. The bases are the same, so you just choose one base out of the two. You do away with the other one, stick to one, and add what is on top. If it was 1 and 1, you were still gonna add it as 1 and 1. If it was 2 and 2, you're still gonna add 2 and 2. Now the bases are the same. We just add the exponents. Now the second one says when the bases are the same and you have a division sign in between. This one says when the bases are the same and you have a multiplication sign in between, you add the exponents. The second one says when the bases are the same, you have a division sign in between, you subtract the exponents. Like here, m times m minus n. The bases are the same, we take one base and subtract d. So if they are in this manner, a to the power of m divided by a to the power of n, it's still gonna be the top one, subtract the bottom one. Always standard procedure. Now the third law says when you have a to the power of m and another n outside, it means these two are multiplying each other. Whatever you have inside the bracket will multiply what is outside the bracket. So these two, meaning you'll just have them like this. Yes, just like when you have 2 to the power of 2, 3. This will multiply each other like this. So you will have 2 times 2, 2 times 3, just like that. Now, when you have two numbers inside a bracket which are multiplying each other, they all both take this power outside, right? So when you have 3 times 4 to the power of 2, that will be 3 times 4, still the same, right? It will just be like this. Now this is how it is. The n is distributed through the two terms or the two variables inside the bracket. Now the fifth one says if you are dividing terms and there is a power outside, the power qualifies or the applies to both of those numbers. Let's say you have 4 over 5 and this is the same as 4n divided by 5n. So it's one and the same thing. Guys, if you are enjoying this video so far, please don't forget to subscribe to the channel if you want more videos like this. Leave us a comment or like the video. Also share with your friends because knowledge is power. All right, in exponents, we also have definitions, guys. So if it's a to the power of n, it means you're going to multiply this a to the power of n. This n can be 5, as I have shown you previously, not previously, in the beginning of this video. I have shown you 5 to the power, maybe it's 5 to the power of 3, which means you're going to say 5 times 5 times 5, right? So this n will determine how many times you're going to multiply this base by itself, right? So any number to the power of 0 is 1. Let's test it out. 5 to the power of 0. There you have it. It's 1. So everything to the power of 0 or multiplied by 0. You can say 5 multiplied by 0. No, that is 0, sorry. So that's going to be 5, only 5. Only anything to the power of 0 is 1, not multiplied by 0. Anything multiplied by 0 is 0. But because we're dealing with exponents, anything to the power of 0 is 1. Right? So, when you have a negative exponent, let's say 2 to the power of negative 3, I shouldn't have a negative exponent. Those are what mathematicians say. So if I have a negative exponent, for this exponent to stop being negative, I will say 1 over 2. I'll just put 1 and get rid of this. So having this 1 changes the sign of the exponent. So this is how my answer should be, not this way. So you have m to the power of negative m. Then we just say 1 over a to the power of m. Makes it positive. Now we get rid of the negative sign. Now let's come here. 1 over a to the power of negative m equals to a to the power of m. So if we are having it in this way, that is 1 over a to the power of negative m. The negative here, when it's like this, we do this part to get rid of the negative. Now when we have a negative already in this form, this is how we will do it, right? We get rid of the 1. Getting rid of the 1, get rid of the negativity. Now let's talk about a squared is an exponent 2. So we have 1 to the power of 2, 2 to the power of 3, or 5 to the power of 2. This thing here is called squared. But if you have or 2, we call this 1 cubed. This is 1 squared. This is 1 cubed, 2 cubed, or 5 cubed. Now we are moving to unlike and like terms. I did this previously in my algebraic question, but we can still do it. This is the same. This is a cat, this is a cat. This is a cat, this is a cat, guys. So the K's are the same. I talked about variables and constant. Please watch that video. Very, 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 very informative, so that you can know this one. So we say 2 plus 3, that's 5k. It's 2 cats plus 3 cats, that's 5 cats. So we have 5a minus a, that will be 4a. 5 cats, you take out 1, you're left with 4. Now we have 3 cows and 1 cow. So 3 cows minus 1 cow, that's 2 cows. This cows. Now we have 5a squared b plus 2ba squared. So this is the same thing. We still have a's to the power of 2, a to the power of 2 this side. So we just add this once. That will be 7a squared b. So unlike terms are different alphabets, right? We have a and we have b this side. So this is a cat and this is a dog. There's absolutely no way we can say we add this and then we have 9 dogs. No, we still have 5 cats and 7 dogs. So there's no way we can minus them. So that is how we simplify. Please watch my previous videos. I went into detail with this part, and I'm not going to be doing that in this video. So 3x plus, they are still not the same. This is x squared, this is x. So there is no way they are the same. This is k cubed minus x cubed. They are not the same. They are not like terms. So this is just how we are going to deal with them. That would be 7k minus 7x. Easy breezy. Now let's say you have a plus a, that is 2a. But when you have a squared plus a squared, is still 2a squared. This, remember, when you have an alphabet without any coefficient in front, we know that is automatically 1. So it's 1 everywhere. So here we have a plus b plus a. So we're going to add the like terms. A plus a, that's 2a plus the b. C plus d, it's c plus d. Now when we have a times a, the bases are the same, we add the exponents. Anything that does not have a power written, which means this is 1. So we'll have 1 plus 1. That will cause a squared. Remember, always. So a squared times a squared equals to a 2 plus 2. That will be a to the power of 4. Now a, b, a. We have these two a's. That will be a 1. This is power 1, 1, 1, because there's nothing written there. This one, it was written it's 2. So a 1 plus 1, and then times b, and that will be equals a squared b, right? So we have c times d, that is c d. All right, now let's go into division. You have a to the power of 3, 5, a to the power of 5, right? So the bases are the same, you minus the exponent. So that's going to be 3 minus 5. Remember I said the top one will minus the bottom one. That will be a to the power of -2. So we have a negative exponent. Remember what the rule says? The rule says this is what we do. And then now we have a to the power of 6 divided by a to the power of 9. We say a 6 minus 9 equals to a. When we say 6 minus 9, that gives us a -3. It's a negative exponent. We don't want that. So we say 1 over a 3. And this is how we have dealt with that. Thank you guys for watching. Come back for more videos. And if you enjoyed this video, please don't forget to subscribe, like, and comment. It helps the channel. Share with your friends. And I hope you're enjoying your holidays.